Hi, I'm Professor David Farina. In today's lecture, we're going to be discussing the Sun, our star, in particular, the heart of our Sun. Let's get started. So what is going on inside of our Sun to produce all of that energy? Well, in short, it's nuclear fusion. But that's something we're going to have to discuss in great detail during today's lecture. What is nuclear fusion? So in the case of nuclear fusion of hydrogen, which is what we're going to be discussing today, we are talking about basically two protons that are being collided together. Now, of course, protons are both positively charged. So don't positive charges repel? They do. And it takes immense amounts of force to push them together. And the immense amounts of forces necessary are really only possible naturally inside of stars, which is what produces the energy. So when we bring those two protons within about 10 to the negative fifth meters from each other, 10 to the negative 15th meters from each other, they will bond together. They will form a new substance, and that new substance is a deuterium nuclei. Now, deuterium is the combination of one proton and one neutron. Now, I thought we had two protons. Well, we did. However, through this collision, we get the emission of something called a positron, as well as the emission of something called a neutrino. So we're not going to get into the details of what's going on here, but just know that we've lost that positive charge. We still have a proton, one of them, but we now have a neutron. And the positron flies off on its own, as well as a neutrino. Now, this proton-proton collision is one of many proton-proton collisions, which we call the proton-proton chain. The proton-proton chain is, as its name implies, a chain, a sequence of events that occur in nuclear fusion. So we have a proton and a proton collide. It emits a positron, and the neutrino is not shown here, but it would be emitted as well. We then end up with a deuterium nuclei, and our positron and electrons fly off together. They hit, collide, and annihilate each other, producing gamma radiation. The deuterion collides with a proton, and they produce helium-3, two protons with one neutron. Now, a second chain reaction has been occurring alongside of this, two protons collided together, producing that same outcome, deuterion and a positron. An electron and positron come together down here and produce an X-ray. And this goes on and on and on and on. The deuterion and this other proton from a proton soup come together and they collide, producing yet another helium-3 nuclei. So now we have from the top and the bottom reactions two helium-3 nuclei coming together. Helium-3 plus helium-3 collide together and they produce helium-4. And those two protons now, we've got two protons together and two neutrons. They produce helium-4, remaining behind are two protons, which show up right here again, or right here. And the chain continues again. So you can see now how this proton-proton chain occurs, and you can see how much energy is produced at all of these different various steps throughout, which makes the sun hot, which produces the light in the form of X-rays that we see. As it goes through its long walk, the X-rays are converted into visible light, and visible light is what we see here on Earth. Now, of course, neutrinos are emitted throughout this process, and as a result, we should observe neutrino emissions from the sun. Problem is that neutrinos are really, really hard to track down. As we've discussed in previous videos, neutrinos come in three different flavors, and those three different flavors of neutrino can pass through everything, you, me, the Earth, without hardly interacting. We need specialized detectors like these here in order to observe them. These neutrino detectors are buried deep under the Earth, so that the only thing that could penetrate the structure that's around them is a neutrino. So next time you go to discover neutrinos, it's going to take a lot of hard work and a lot of energy, and I recommend leaving it to the experts. Thanks a lot for watching today's video about the Sun, our star, in particular the heart of the Sun. Thanks for watching this video. If you liked it, please click that like button. If you'd like to learn more, please subscribe. And if you'd like to get a notification each time I make a video, please click the bell at the bottom. Thanks again, and have a wonderful rest of your day.